Okay then, so our first video, and hopefully this will be about 5 minutes long, is going to be on chemistry. So I thought first of all we do chemistry, and the topic is bonding diagrams. Okay, now the whole point is I want to keep this short, but as you know there are two types of bonding diagrams you've got to do. You've got to do ionic bonding diagrams and covalent bonding diagrams. All right, now with this video we'll only manage ionic today, but ionic is very simple. If it's a metal plus a non-metal, it's going to be ionic, and obviously if it's a non-metal and another non-metal, it's going to be covalent. All right, so first of all we'll look at metal and non-metal. So the most important thing is that metal atom loses electrons and the non-metal gains electrons. Now, what does that mean? Well, once they've lost electrons or gained electrons, they form an ion. So if you lose electrons, you're going to be a positive ion. And if you gain electrons, you're going to be a negative ion. So that's important. Now, both metal and non-metal gain and lose to attain what we call a noble gas electronic configuration. Okay, so that's all you got to know about ionic. All right, this is the theory behind it. So let's do something. Let's try and do a few. We'll try and keep it relatively short, like the video. So the first one, let's do sodium chloride. The bonding diagram for sodium chloride. Okay, so let me do this. First of all, sodium. There's sodium and there's chlorine. First thing you've got to do is understand the electronic configurations. Sodium is 281 and chlorine is 287. Okay, so now I'm going to draw these atoms. Okay, and on the atoms, I'm going to put the valence electrons. So sodium, that is the valence electron for the sodium, and that's the valence electron for the chlorine. So sodium's got one valence electron, and chlorine has, let me do it in a different color so it pops. Chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. Obviously, as you can see, I've given the sodium crosses, okay, and the chlorine I've given dots. So these are often known as dot and cross diagrams or something like that. So there you go. So sodium has 1 electron and chlorine has 7. So what's going to happen now is, well, this electron from the sodium is going to go over there to the chlorine, and you're going to get ions formed. So let me get that nice color again. Sodium is going to form a positive ion because it lost 1 electron, and the chlorine, let's do this nicely, green. The chlorine is going to have 1, 2, 3, 4, 5, 6, 7, and 1 red one, because the red one comes from the sodium. Okay, and now we could put this in brackets. We put them in brackets to show they're charged. And there you go, that's the bonding diagram for sodium chloride. Now, if you look at the ratio, for every sodium, there's 1 chloride. By the way, these, before they move around, before the electrons move, these are called atoms. That's a sodium atom, and that's a chlorine atom. Afterwards, once they've gained and lost, they become ions. So that's a sodium ion, and chlorine changes its name. It becomes a chloride ion. So chlorine atom, the chloride ion. So as you can see, the ratio is 1 to 1. So it's 1 to 1. So therefore, the formula for sodium chloride is simply NaCl, and that's it. Okay, it's as simple as that. So let me draw a line down there. Let's do another one. Let's do potassium phosphide. Okay, so first of all, I'm going to draw the potassium, K, and then phosphide is P. Now, before I did that, I should have done the electron configurations. Potassium is 281, phosphide is 285, and I'm going to draw this. I am only going to draw the valence electron, so the 1 and the potassium and the 5 in phosphorus. Okay, so there we go. Potassium has 1 electron, and phosphorus has 5. 1, 2, 3, 4, 5. Now, to get noble gas configuration, obviously, let's pick a nice color. 1 potassium isn't enough. We need 8. We need 8 around the phosphorus. So to get 8, we need 3 potassiums. So this is what's going to happen. 1, 2, 3, each with its own valence electron. There. And now what's going to happen is that one's going to go there and that one's going to go there. So what we're going to end up with is a phosphorus, like that, and 3 potassium ions. I'm just drawing them around there like that. Okay, now the potassium, each potassium loses 1 electron. So that's K plus, that's K plus, and that's K plus. But the phosphorus had 5 of its own, 1, 2, 3, 4, 5. And then it gains 3 from 3 potassiums. Okay, so there we go. So since it's gained 3, it's 3 minus. All right. Now let me move this up a tiny bit. Now if you look at the potassium ion and the phosphide ion, okay, obviously there's 3 of those and there's 1 phosphide ion. So the formula of potassium phosphide is simply K3P. Okay, this is NaCl, this is Kp3. And there you go, that's it. Now, as I said before they lose, these guys are atoms. And this is a phosphorus atom. But once it loses the electron, this guy changes his name to become a phosphide ion. So that's why this is called potassium phosphide. Now, I think let's try and squeeze one more in. Let's do, they're all the same though, aren't they, really? Let's do calcium, I don't know, calcium chloride. Let's do the bonding diaphragm. Now, first of all, as I've already stated, that's a metal. And this guy's a non-metal. Okay, so therefore it's going to be ionic. That's the first thing you want to know. Now let me do my things. Let's do a different color. Let's use this blue. Calcium and chlorine. Calcium is in group 2, so I'm going to do 1, 2 electrons there. Chlorine is in group 7. So 1, 2, 3, 4, 5, 6, 7. And now, as you can see, hopefully as you can see, one of these electrons is going to go there, and then the chlorine is done, then it's full. So we need another chlorine to soak up the other electron from the calcium. Okay, so the other one is going to go in there. And now we end up with Ca. It's lost 2 electrons, so it's 2 plus. And let's try a different color. We'll use that color. And 2 chloride ions. All right, what colors did I use? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that's the ones from the calcium are red. And let's make it nice. Each of these has only gained 1, so it's -1. And this is -1. I'm drawing circles around them. I don't know why I do that. I often do that, but there you go. So now if we look at this a bit more closely, calcium ions, the ratio of calcium ions to chloride ions, well, there's 1 of those, and there's 2 of those. So the formula for calcium chloride is CaCl2. And there you go. And that is the bonding diagram for calcium chloride. Okay, so I want to keep this short, so I'm going to stop here. But hopefully that's ionic compounds, and you've got to play with them yourself, but you can only do them if you have a metal plus a non-metal. They don't work otherwise, okay? So find some metal.